So the today's topic is principles of parallel and distributed computing. So as we know, the cloud computing is nothing but the utilization of IT infrastructure or services application through the internet. So that is called cloud computing. So in the major, they are providing the three kind of the services. The first one is the infrastructure and services. Second, platform as a services. Third, software as a services or application as a services. So wait a minute. So the first one, eras of computing. So here there are two fundamental types of computing. The first one is a sequential era. Another one is a parallel era. So the sequential computing era began in 1940s, and then the parallel computing is followed after 10 years, so 1950s. There are four key elements of the computing were evaluated. So based on the architecture, compiler, and application and problem solving environment. So as you can see in the graph, the architectures and the system, software, compiler, and application, and then problem solving. So these are the main key elements which are developed over the decade for the computing eras. So the computing era started with the development of the hardware architecture. So it actually enables the creation of the system software, particularly in the area of the compiler and operating system, which help us to support the management, like the system management, and to develop the applications. So the development of application and system are the major element which help us to solve the problem solving environment, which help us to design all the environment and platform which facilitate the engineer to develop the application which help us to solve the problems. So the it contains the three phases: the research and development, and commercialization, and commoditization. So as we know, so the first of all, the R&D team, that is research and development, so will research the all the requirement or all the problem. Based on that, they come up with some analysis and some theoretical approach, so in order to develop the product. After that, they will after taking all the requirements or for the particular problem, they started to develop the application. So after that, they will commercialize the product, so and then commoditize the problem. So these are the three major steps of the development of the product. So after that, so we have to see the parallel and distributed computing. So in previous classes also we seen what is parallel and distributed computing. So when you have any idea what is parallel and distributed computing? So in slide itself, I maintained the parallel. It's a tightly coupled system. So sometimes the parallel and distributed computing are used interchangeably. So but the the both can be referred as a tightly coupled, but it contains a slight difference. So distributed computing is nothing but it covers the wider range of the system, so which is located in different network environment. The first thing is a parallel computing. So the parallel computing refers to the process of breaking down the larger problem into smaller problem, and the smaller or the similar part can be executed simultaneously by the multiple processor, so which shares the same memory, that is a shared memory. But in case of the distributed computing, So it is like a model which contains the unique memory, and all the process will be handled separately, but the communication will be taken place over the shared media through the messages. So we'll see the one by one. So the parallel computing. So are you getting any idea from seeing this picture of parallel computing? So okay, the term parallel computing refers to the computation here. As you can see, the problem is divided among the several processor and they sharing the same memory. So they will divide the problem or divide the computation into multiple smaller parts. They will assign the each part to the separate processor, but the all the process which shares the same memory. So the each process is the same type. The each process must be the same type, and it must contain the same capability which other has. So they must be the same kind of processor, and also they have must be the same kind of data also. So it, as I said, the it shares the same memory area. So the shared memory has a single address space, which help us to access the all the processor which we assign. So as you can see here, the multiple processor is there. So using the single address space, so which help us to refer or access all the processor. So the parallel programs are then broken down into several units of execution, so that can be allocated to the different processor, and it can communicate each other by a means of the shared memory. So and then the distributed computing. So from the image, you can see the distributed computing. It contains the unique memory. So each system contains the unique memory and also the processor. So it allows the computation to be broken down into the unit and the executed concurrently on the different computing element. So they contain the processor on different nodes, or it might be the processor on the same computer, or the core within the same processor. So the maximum, so it will contain the unique memory and also the unique processor, but the all the systems are communicated over the same network. So as you can see from the picture, the parallel computing shares the same memory, but the computation or the problem will be divided into multiple segment, and it will be allocated to the each processor. So here, so it contains the each system contains separate memory and also the processor. So here also they will divide the process like divide and conquer method. So they divide the each process and it will be allocated to each individual system. So then the process or the data will be transferred to the internet via the shared applications, or the internet, or any kind of application which help us to share the data. So it is a major difference between the parallel and distributed computing. So is there any doubt about the parallel and distributed computing? So as we know, the computer system, it's a silicon based processor chip. So we are not having the single processor chip. So it's like the multiple processor will act as a single component in our computer. So for example, as you can see the RAM. So if you open up the RAM hardware, so you can see the multiple processor. It connected in a serial phase. So the multiple components of the processor will act as a single processor. So in order to perform the task. So nowadays the all the laptops are supports the parallelism, like it helps us to run the multiple tasks at the same time. So like we can able to um, hear the music at the same time. We can work on the any document, like the document or editing or drawing on the another application. So here we can able to work on the multiple process at the same time. So that is a parallelism. As you know, the parallelism in the sense, so working on the multiple tasks at the same time. Okay, what is parallel processing? So have any idea what is parallel processing? I already explained it, so it's a 2 mark question, so that's why I put it in separate slide. So what is parallel processing? And the slide உள்ள யாராச்சும் read பண்ணுங்க பார்க்கலாம். It will be better. So just read. So what is given in the slide? So anyone? Processing of multiple tasks simultaneously on the multiple. Okay, can you hear me? Excuse me. So wait a minute. So thing. Hello. நான் பேசுறது கேக்குதா எல்லாத்துக்கும்?
Yes, sir.
Yes, sir.
Okay. So the parallel processing is nothing but the process of multiple tasks are simultaneously assigned to the multiple processors, that called the parallel processing. So the parallel program, so the consists of multiple active process, like the task that is simultaneously solving the given problem. So it's the given task or the given problem will be divided into multiple subtasks using the divide and conquer technique. Divide and conquer technique. So and the each subtask will be processed on different processor or the CPU. We can call it as a CPU. That is a central processing unit. So the programming which is running on multiple processor system using the divide and conquer technique is called as a parallel programming. So the programming on the multiple processor system using the divide and conquer technique is called as a parallel programming. So it is also one of the 2 mark question. So one more thing, so you have to take notes. So whatever we are explaining in whatever we are given in the slide, so we have to submit all the notes at the end of the class every day. So the principal instructor to check whether all the students are taking the notes or not. So that is also very important. So if we are so from today onwards, so you have to take all the notes whatever classes we are taking. So it might be evaluated at the end of the day or weekly once. So okay. So the next, as we know, the parallel processing. So the development of the parallel processing is evaluated based on the many factors, like the computational requirements, so which help us to work on the scientific or business computing. So it will be very it requiring the high speed or the high computational processing of the data. So like for example, if you are working on the life science project or aerospace project or some geographic information system, the GIS project, so these things are require the high computational speed. So the next one, it's like the sequential architecture. So like we have to work with the multiple processor, so in order to process the large amount of data or the large problem. So and also it has to work the sequential with the the large amount of data. And also we have to, so there need to be an improvement in the hardware devices also. So and also they have to work the technology of the parallel processing, and also we have to work with the network development, so in order to improve the development of the processing. So the next thing, hardware architecture the hardware architecture for the parallel processing. So the core element of the parallel processing is a CPU. So the based on the number of instruction and data stream can be processed simultaneously on the computer system, are classified into three categories. The first one is a single instruction, single data system, and the second one is a single instruction, multi data system, and the third one is a multi instruction and single data system. The finally the multi instruction and multi data system. So I'll explain the first one, that is a single instruction and single data system. So then you have to say the second, that is a single instruction and multi data system. So it's very easy. From the picture you can able to understand it clearly. So as you see, the single instruction and single data system. So here the SSSD computation system is a uniprocessor machine. So it is a uniprocessor machine. So it's capable of the executing the single instruction which operates on a single data stream. That means a single data. So the machine instruction are processed sequentially. So hence the computers, the adaptive model called the sequential computers. So it will work on the data one by one. So like the one input will be given based on the single input and single instruction, the data will be processed here. So the all the data, which is all the instructions and data to be processed, have to be stored in the primary memory. So I think you know what is primary and secondary memory. So the all the data will be stored in a primary memory here. So here the speed of the processing element, so it is very limited. So as you can see, so it's work on the single data and also the single instruction. So from the second, it's a single instruction and multi data system. So here the hello. So if you're not understanding, you can stop right there. So and you can ask the questions. So if you have any doubts in it, so if you are not clear with the topic, so you can ask at the any time. Okay. The second one is a single instruction and multi data system. So what is instruction? Any answers? What is instruction?
Commands.
Commands.
Some action.
Okay. Some actions.
Guidelines.
Guidelines. Exactly. So instruction means it's a guidelines which need to be followed. So here, so they will use a single instruction, but they are using the multiple data stream. That means a multiple data set. You can say it's a multiple data set. So here the system in a multiprocessor machine. So it's capable of executing the same instruction on the all the CPU, but it's operating on the different data stream. That means it works on the different data set. So the machines are suitable for the SIMD. So it is mainly works on the scientific computing. So as we know, they are using the same kind of instruction, but they have to process the the lots and lots of data. So it's mainly works for that. So it's mainly works on scientific computing. So because the scientific computing, it involves the lot of the vector and matrix operations. So and then third one, it's a multiple instruction and single data system. So so as a word from the word itself you can understand. So here they have the multiple instruction and they are using the same data set. So what kind of application will be suitable for the multiple instruction and single data system? So any guesses? What kind of application will be suitable for this the MISD system? So here the computing system is a machine. So it is a multiprocessor machine. So which capable of executing the different instruction on the different system, but the every process will be processed using the same kind of data set. So what could be the application? So any application or any guesses? அதாவது ஃபர்ஸ்ட் டைப் என்ன அப்படின்னா ஒரு சிங்கிள் டேட்டா இருக்கும், சிங்கிள் இன்ஸ்ட்ரக்ஷன் வச்சு ஃபாலோ பண்ணி ப்ராசஸ் பண்றது. அந்த ப்ராசஸ் வந்து சீக்வென்ஷியலா நடந்துகிட்டே இருக்கும். ஓகேவா? ஸோ அடுத்து என்ன அப்படின்னா ஒரு சிங்கிள் இன்ஸ்ட்ரக்ஷன் இருக்கும், ஒரு அந்த சிங்கிள் இன்ஸ்ட்ரக்ஷனை ஃபாலோ பண்ணி மல்டிபிள் டேட்டா செட்டை ப்ராசஸ் பண்றது. ஸோ ஃபார் எக்ஸாம்பிள் சயின்டிஃபிக் அப்ளிகேஷன் வந்து ஒரு சிங்கிள் செட் ஆஃப் ரூல்ஸ் வந்து வச்சிருப்பாங்க. பட் வந்து அந்த டேட்டா செட் வந்து ஹியூஜ் அமௌண்ட் ஆஃப் டேட்டா செட்ஸ் வச்சிருப்பாங்க. ஸோ அதில் வந்து மேட்ரிக்ஸு, வெக்டர்ஸோ இந்த மாதிரி மேத்தமெட்டிக்கல் கால்குலேஷன்ஸ்லாம் ஜாஸ்தியாக இருக்கும். ஸோ அந்த மாதிரி ப்ராசஸ் பண்ணுறதுக்கு இந்த சிங்கிள் இன்ஸ்ட்ரக்ஷன் மல்டி டேட்டா யூஸ்ஃபுல்லாக இருக்கும். ஸோ அந்த மாதிரி ஸோ இந்த தேர்ட் டைப் எந்த மாதிரி அப்ளிகேஷனுக்கு யூஸ்ஃபுல்லாக இருக்கும்? இந்த மல்டிபிள் இன்ஸ்ட்ரக்ஷன் அண்ட் சிங்கிள் டேட்டா சிஸ்டம். ஸோ எந்த மாதிரி இதுக்கு யூஸ்ஃபுல்லாக இருக்கும்?
Automatic washing machine, sir.
Yes, correct. Automatic washing machine. ஸோ இந்த மாதிரி டிவைஸ் ஓரியன்ட் எக்யூப்மெண்ட். ஸோ அதெல்லாம் ஒரு சிங்கிள் கைண்ட் ஆஃப் டேட்டா செட் இருக்கும். பட் இன்ஸ்ட்ரக்ஷன் ஒவ்வொரு பட்டனுக்கும் we have to give the different instruction. பட் டேட்டாஸ் எல்லாமே சேம் தான். தட் மீன்ஸ் தி இன்புட் என்னென்ன கொடுக்குறோமோ ஸோ இன்புட் வில் பி டிஃபால்ட் ஒன், பட் they have to work on different instructions. So each button வந்து நம்ம ப்ரெஸ் பண்ணும்போது so they have to execute based on the different instruction. So that is a third one. So what about the fourth one? The fourth one is a multiple instruction and multiple data system. So it is capable of executing the multiple instruction on the multiple data set. So here the every process will have the separate instruction and also separate data set. Okay, here so the last one will suitable for all kind of application. So whether it's a scientific application or device oriented application or the normal basic system application. So here the last model will be suitable for all kind of applications. Here they will work on the shared memory concept and also the distributed memory concept. It can work on so any concept. But in previous systems, the the first one always store all the data in the main memory. So some of the system will share the memory, some of the system it won't. But the last one, so that is the MIMD. So it capable of working all kind of memory system and also it can able to work on any kind of application. Okay, is it clear? Everything is clear? Any doubt?
No, sir.
No. Okay, thank you. So the next one, so approaches to the parallel programming. So here, the sequential program is the one so run on the single processor and also has a single line of controller. So here to make many processor to work on a single program, so we need to follow some methodology. So like the program must be divided into the smaller independents in order to assign the each uh, subpart to the each processor. So here they are the performing the parallel programming approach based on some factor, that is it dividing into three types. The first one is a data parallelism, and second is a process parallelism, and the fourth one is farmer and worker model. Uh, the it is the everything is work on the task level parallelism. So we will see the what is task level parallelism and those things in next classes. So the first we will see what are this type, what is data parallelism and process parallelism and farmer and worker parallelism. The first one is the data parallelism. So it is a divide and it works on divide and conquer technique. So it split the data into multiple data sets. So each data set is processed on the different system using the same instruction. So that is called data parallelism. So this approach is suitable for the machine-based system. And the second is the process parallelism. So the process parallelism, the given operation has the multiple activity, so that can be processed on the multiple processor. So multiple activity can be processed on the multiple processor. So that's called the process parallelism. So the last one is a farmer and worker model. So it's nothing but the job distribution approach is used here. So like the one processor is configured as a master and other remaining system will be configured as a slave. So the master will assign the jobs to all the slaves. So on the completion of the task, the master will collect all the results from the slave and it will conclude the result. So this approach is called as a farmer and worker model. So the first one, data parallelism, is works on divide and conquer method. So here, the first method, the data will be split into multiple data set. So the each data set will be processed on different system using the same instruction. So that is data parallelism. So here, the second one is a process parallelism. Here, the multiple process will be multiple work will be processed on the multiple processor, that is called process parallelism. The last one is a farmer and worker model. Here they are dividing into master and slave. So the master system will assign the work or the job to the slave system. So and then after the the completion of all the works by the slave system, it will collect all the data and process it. So that is a last approach, that is a farmer and worker model. So is it clear? Any doubts?
No, sir.
Okay. So